a continuation of our introduction to solving linear equations. Recall from the previous video that we always want x alone and naked. In other words, we want to know 1x plus nothing minus nothing, just x equals some number, and it's the number that makes our equation true. So this, what we're talking about here when I say x alone and naked, this is once we've done our cleanup in step 1. So we're looking at these two questions will help us with steps 2 and 3. These questions that I'm going to ask, what's in the way and what's it doing with x? Well, basically tell us what to do. And once we see what's in the way that we want to get rid of and what's it doing with x, we will undo it by doing the opposite. And important. Oh, let's get there. You can do anything you want to an equation as long as you do the same thing to both sides. So we're going to be using that all the time when we solve linear equations. If you do something to one side, you've got to do the same thing to the other side. The first example that I'm going to do is using all of the steps together. When we go on to 3.1a and 3.1c, we're going to go backwards a little and do it bit by bit. But let's take a look at this first example so you can see what we're talking about in those 3 steps. So do you remember the first step is always, can you clean up? So you're going to take a look at each side separately, and what I'm going to do is I'm going to draw a line so we can clearly distinguish between the two sides of our equation. Okay, just looking at the left-hand side, is there anything that we can do to clean up? Yes, we can simplify that by using distributive property to distribute that 2 across those parentheses, and we would get 2x plus 2, and that side is finished. There's nothing more we can do there. Over on the right, there's a little bit more we can do. Again, we're going to simplify by distributing that 5x plus 10, and we still have the minus 2. We can do a little bit more over here on the right to simplify 5x plus 8. So right now, we've got this equation. It's just a simplified form of the original, and I'm going to note that all we've done here is step 1. We're just simplifying each side separately of the equation. So now we're ready to get all of the variable terms on one side and all of the constant terms, the plain old numbers, on the other side. So when we take a look at this, I'm looking at, well, here's a variable term and here's a variable term. We've got to get them on the same side of the equation. So let's decide, and it doesn't matter which side, but I'm just going to say I want all of my variables on the left, and that automatically means then we want all of our plain old number terms on the right. So if all of the variable terms are going to go on the left, who is out of place? The 5x is out of place because he's a variable term and we want him on the left. So what is 5x doing over on the right? Well, he's being added. So that tells us we want to do the opposite. We want to subtract 5x, and do you see what will happen when we subtract 5x over on the right? These two will cancel. 5x minus 5x is 0, and 0 plus 8 is 8. So we've gotten rid of the variable terms on the right. But if we do it to the right, we've got to do the very same thing to the left. So if I've decided that I want to subtract 5x on the right, I've got to subtract 5x on the left. So let's see the result of this. 2x minus 5x is 3x, and we still have our plus 2, and as we mentioned, 5x minus 5x is 0, and 0 plus 8 is 8. So we're making progress because now all of our variable terms are on the left. So now who is out of place? Well, we've got to think about getting all the numbers on the right, so who's out of place is this little 2 on the left. How do we get him off the left-hand side? Well, what is being done with that 2? It is being added. So we are going, whoops, I'm sorry, I just noticed a mistake. That's a minus 3x. So if we want to get rid of that plus 2, do the opposite. We're going to subtract 2. So we subtract 2 from this side, and let me clean this up a little bit without the lines. And we know we can do that as long as we do the same thing to the other side, subtract 2. So the results of that, now we've got on the left negative 3x, and you'll notice the plus 2 minus 2 equals 0, so we don't even have to write that. And over on the right we have 8 minus 2, which is 6. So what we've done so far in these 3 steps, getting all the variable terms on one side, all of the number terms on the other side, that was step 2, and you remember we used addition and subtraction. And I'm going to have to create a little bit of extra space here. So now we're almost there. We've got all of the variable terms on the left, all the the constant terms on the right, but we still have something in the way. We've got that negative 3x. So what does it mean when you have a negative 3x? Let's put that over on the side. Negative 3x means negative 3 times x. So what's the question then is, what is that negative 3 doing with x? They're being multiplied. So to undo that, what do we want to do? We want to divide the opposite. We want to divide by negative 3 because that's going to cancel here. But if we divide the left-hand side by negative 3, we've got to divide the right-hand side by negative 3. So at this point, we've got on the left x, woohoo, we got it alone and naked, and on the right, 6 divided by negative 3 is a negative 2, and we have solved our equation.